Good everybody, it's a pleasure to introduce you to Sébastien, Director of AI at Translated and the Managing Director of the Pi School. It's a pleasure to have you here, Sébastien. He will be talking our upcoming conference, Pi for AI, which will be held in Pavia on March 16th at the headquarters of CVision. It's a pleasure to have you, Sébastien. Welcome.
Thank you. Great to be with you.
Thank you so much for accepting our invitation, and thank you so much for speaking. Let's get started. So let's talk about you. Who are you? What does your job at Translated Pi School revolves around?
Oh, okay. So at Translated, we sell professional translation services, essentially, which means a lot of work by humans powered by technology. My job as the director of AI is to make sure that technology works. And because a lot of it is AI, well, it's machine learning, it's deep learning, it's machine translation, it's transformers from the very beginning of transformers, if you want to know. I think we were on transformers in production before Google had transformers in production, even back in 2017. That is my job in Translated. In Pi School, we have a quite different activity, but I thought it's worth mentioning here. Pi School, we do training and professional training in AI and rapid prototyping. So we have this program, 8 weeks, one problem. We get people apply to Pi School and they sit down and work on this one business problem that we put in their hands, that we have sourced for them, essentially. The entire thing is sponsored by industry. So industry comes forward with problems. We solve them using the state of the art. And then we put the MVP, the minimum viable product, the prototype we've built, back in the hands of the industry that sponsored us. And they do with it what they need to do. So they turn it into a product or a service. And my job at Pi School is as the managing director. So I take care of a bit everything.
Wow, that is really a lot of stuff, and we'll dissect a bit of it during this small interview. But let's get started with one thing. You do a lot of research, so we can expect an outstanding talk at the upcoming conference. So can you share with us some detail about the conference, the title, and what you will be talking about?
Okay, yeah. So, okay. First off, I can say that the talk is kind of grounded in a big research project that we recently won. So the project is called MeTween. I'll say a word about the project itself during the talk, but essentially the topic of the project is the reason why I decided, to speak about this topic at the conference. And it's a topic that is sort of close to my heart, has been for a very long time already. And that's to do with speech and with neural network models for speech. So when I say speech, I mean not just speech recognition, which is one of the sort of main pieces of technology that's in the speech area, of course. I don't mean only speech generation, which text to speech, which we have got recently in the last year, maybe 2 years. We get more and more realistic and natural voices, synthetic voices come out of research, move to products in industry, and this is obviously fascinating developments. And all, like, these are two bits of what's going on in speech. But speech also means, and this is where foundation models are especially important, it also means stuff like speech to speech translation. So I speak to you in English, but maybe you want to hear Japanese, and it'd be good if you could maintain my timbre, my speaker identity in the speech that's rendered in Japanese. And it would be even better if, when we have this video conference here, for instance, if the lip sync, so the kind of lip reading that you might do of me, would be aligned with the words I'm saying. It would be brilliant if not just the lip sync, but then also the head movements and maybe also the gestures I'm doing, all of these bits which participate, which are nonverbal content, communication content, if all of this was sort of smoothly aligned so that any rendering of new speech would look like it's the original speaker speaking. And so just like we've seen with LLMs, what foundation models can do in text, language, but the text form, what I like to speak about in this talk is what foundation models can do for speech with all these dimensions. So I was speaking of speech as audio, obviously, but also speech as video, the video channel of speech. So seeing somebody like we see each other here in a video conference setting. In the project itself, in between, we take this further into applications, avatars for video conferencing, for instance. I will speak less about this during the talk. I'd like to keep the talk about sort of concrete technical topics of the day. And so I'll speak more about neural architectures that are useful to build foundation models, the kinds of data and the kinds of tasks that we can expect to have a foundation model for speech carry out. I'll look at a few sort of existing works in this direction. So some people have already started working on this. It's very recent still, but a couple of things are happening. And what's interesting, I think, especially for the audience, then is to understand what kind of models can be turned into foundation models and what kind of models are not adequate for that. A foundation model is a very specific type of model because it's one that is trained in what's called an unsupervised way. So it consumes data that is not labeled, which is plentiful. In the case of speech, you can think of just speech recordings, but you could also think of video recordings where you have a person speak, because this is the natural way in which speech video occurs. Right? It's synchronized between the video and the audio track by nature, and that's super good already. But it's not it doesn't require further processing or further labeling, which means that it's a type of data that is cheap to acquire. It's easy to acquire because it occurs in nature. And once you have this type of data, foundation models are the ones that can learn from it. They're usually very big models, just like LLMs are pretty big models. They learn to do what's called representation learning in this unsupervised setting. And then you can change their architecture to put them at work to what's called downstream tasks. So you decide on, say, for instance, you want to do speech recognition then. Okay, so you pre-train your speech recognizer with unlabeled speech, and then you fine-tune it usually with a bit of transcribed speech, so it knows how to transcribe, but it also already knows about acoustics, about say the likelihood of phonemes following one another, of what kind of sounds speech is composed of, as opposed to any speech. And so when you move your foundation model to this downstream task, essentially you specialize it to what you want it to do. And that's where it becomes applicable in some practical use case. All these things packed into one talk in Pavia in a couple of days.
Wow, this is bonkers. Okay, this is so amazing. So this pairs so many questions, but the first one would be, these kind of foundational models you're talking for speech are multimodal models, basically, right?
Yeah.
And so what kind of data do they consume? How do you decompose this raw speech, and how do you encode data that comes from so many different sources? How do you envision an encoder that handles text, sound, and also video?
Yeah, so that's a very good sort of architecture, I would say, type of question. So one thing to keep in mind is that the type of models that we are speaking of are a bit different from what people usually mean when they say multimodal foundation model, say, or multimodal large language model or stuff like that. Because often enough, what people mean is, or what they're speaking of is, stuff like captioning models. So multimodal is often thought of as, say, an image and then a description of the image. Or imagine a piece of music and text that describes the music. So that then in applications, you can think of, you write the description and you get the music generated for you in a sort of generative setting. Same goes for images. Same goes for video, where you have maybe applications like action description or action labeling. You have a piece of video, and the thing that is contained in the text is the description of what's going on in the video. What we're speaking of is very different because we have a complete synchronicity between the different modalities. The speech is aligned with the video, and the text is aligned with the speech. The text being literally the transcription of the audio channel. Okay, so that's very different from the type of multimodality and multimodal models that we see, come out in research, for instance, and that people mean. So, going back to your question, it's this very specific type of multimodality that we're looking at, and in terms of encoders, so clearly, depending on the modality, you'll have a sort of encoding head, or the encoder itself, the thing that turns the stream, the stream from that specific channel into embeddings in some latent space. The piece that does this is at first different between modalities. So you'll have a separate encoder, and they're very good encoders already, for the audio, for the video, and for the text. The secret, however, is that, or at least this is one of the possible architectures that you might think of, once you have these embeddings, well, if you train your model right, you can have it so that the embeddings land in the same latent space, which means that the embedding you obtain, imagine just from the video track of our interview here, is very close to the embedding that you would get from the audio track. And the same with the text track, the text string. This would mean that you are creating a latent space that is modality independent, okay? Which is a bit the same kind of thing that happens when you work in translation. Imagine text translation. You're essentially you're creating a language independent representation of, say, an input string in English, and you're then decoding that representation with a decoder that will take that same embedding, but will turn it into Italian text. And that then is, if you plug one to the other, it gives you a machine translation system that turns English text into Italian text, having some intermediate representation. So this is one of the ideas that you can pursue. It's one of the types of architectures that you might pick to build this kind of foundation models that we're speaking about.
Wow, yes, it does. It's very interesting. There will be so many follow-up questions to ask, but I think participants will have the time to do that at the conference. But going down to a more, say, earthly subject, ChatGPT kind of changed the way we think of AI in the last couple of years, but it kind of feels that we haven't talked much about translation and this kind of really advanced use case, which involves basically all modalities of speech, text, and voice. So where was translation in AI in the past years, and how, if so, did the release of ChatGPT or LLMs for natural language propel this field further in this couple of years?
Yeah, there's been so much happening. It's hard to decide where to start. So first off, it's clear, it should be clear to everybody at the conference, but it's worth insisting. The very technology that we've been using to do machine translation ever since 2017 is transformers. Transformers were then the building block for LLMs as we know them today. So it's very revealing to realize that the very best generative models we have for language today, and this really extends because transformers, work in other fields as well, but at least for language, it's very interesting to see that these LLMs come from that corner of NLP, which is machine translation. Okay, so this is where it all comes from. And so at Translated, we've been doing machine translation in support of human translation for like the 20 years, it's more 20, almost 25 years of our existence, with a range of architectures. And obviously neural architectures, the transformer, especially, this is the architecture of choice that we have in place in production processes since they came out in 2017. And there's something really interesting happening now, which is that with the language models that are coming out, the ones that are trained on running text on free text, as opposed to transformer machine translation models, which are trained on what we call bytext, i.e. tuples, say one sentence in English, one sentence in Italian, and the model is trained to transfer from one to the other, is what we call bytext data. So in the case of LLMs, we only have running text, and it's obviously much more easy to source, which is what makes them foundation models as per the definition I gave earlier. So what they are very strong on is sort of the understanding of the world, quote unquote, that stems from being exposed to very, very large quantities, like orders of magnitude more text than the translation models. So these models, the LLMs, have got this representational power, which is much stronger than machine translation transformer models, because they've seen so much more text, but in an unsupervised way. And so what one would like to do very spontaneously is to exploit this to improve the type of intermediate representation maybe that machine translation models use, make use of this world understanding power that's sitting inside these LLMs, the weights of the LLMs, put it at use to improve the results of translation. And there are different ways to do this. The most simple of which is just to go and prompt your favorite LLM to say, translate the following sentence into blah. Okay, this often enough works, but it's not there yet. And dedicated MT models are still sort of more robust, better across a range of tasks than LLMs we're seeing. But there's a lot of innovation and R&D going on, because this is not the only way. You can also do task fine-tuning. You can employ LLMs to do subtasks of machine translation. You can enrich LLMs with stuff like glossaries, guidelines, dictionaries that you can't readily apply with machine translation models. So there's a ton of avenues in which you can exploit LLMs to carry out the machine translation task that were just not possible before. And this is obviously very exciting, because it means that we're getting better and better, and the quality of translation that comes out of these hybrid models, presumably, or these very specific usages of LLMs, this is getting better by the day. And at some point, I'm pretty sure we'll have a new, in the translation industry, a new paradigm change, where it's not going just to be this type of MT transformer encoder decoder architecture that we've known for 6 years that are working best, but maybe something derived from LLMs.
Wow, this is amazing and really exciting. So, and this is also a lot to digest. So I would like to ask you, given also your experience as managing director at Pi Campus and Pi School, what kind of advice would you have for an individual aspiring to enter this field? Where would you like to start? And what would be the most important piece of advice that you would give them?
Okay, so I think the most important thing is not to get lost in the front of overwhelming innovation, but instead to foster curiosity and an ability to detect the very important business problems that we have, And based on the problems that exist, saying business problems in a very general sense, okay? So it could mean problems related to sustainability. It could mean business problems in one specific industry. It could mean problems related to tools or products, very generic. Identifying the problems and only then trying to find solutions in the state of the art to solve these problems. And it's not the other way around. Okay, it's not innovation first, and then, I've got this hammer, I need to find the nails that go with it. No, it's rather, I need to nail this, let's find a hammer for it. So it's this point that I want to drive home with people. It's the sound, the best way, and if you look at many of the successful startuppers out there, this is exactly what they put their focus on day to day. It's identify a very important problem that matters, that has impact, that something that people want to buy, a problem they want to solve, and only then look around for technical solutions to solve these things. And I think this is a very healthy way to sort of laser focus on the stuff that's very important, that's most important, ignoring a lot of the noise that is bound to happen when you have such a thriving innovation as we're seeing it these days.
Wow, thank you. I think there's time for one last question and a half, and that would be, how do you put this kind of advice that you just gave us in practice in your experience at PySchool and PyCampus? What do participants do, and how are they taught to be hammer inventors, but actually more of a nail seeker role?
Okay. Yeah, I mean, so this principle is how we designed this program I spoke about earlier, PySchool of AI, which is this 8-week programs, engineers applying, coming to us and working on these problems. So it's very inspired from how startups function, and also the idea that you need to you define the problem and then you iterate over solutions, like generations of solutions to that problem, but still trying to solve the very same, like keeping the problem constant and still solving the same problem. So the design of the program, if you will, is inspired by this idea, by what I just explained, in that there's a part that happens before our fellows, we call them, come onto the program, which is at PySchool, we source the problems. So this is something that, to keep the experience of our fellows intense, we do beforehand, so that when they come, we have already found the problem for them. And we have a guess based on our sort of professional judgment, educated judgment, that it can be solved with state-of-the-art in AI as of today. But we don't know the solution. And in fact, nobody knows the solution, because usually they're unique problems. Nobody's worked on them before. And often enough, they're also problems that are specific to a given context. And they might also be specific to some data that the industrial partner that we have collected. So we need to make that data work to solve that problem. And this poses, sort of extra constraints, because maybe the data is not the right one, or it's not enough, or it's very costly to label, and so we need to find a supervised way to exploit that data to solve that problem and so forth. So we do this work beforehand, and then we iterate through potential applications of the state-of-the-art during these 8 weeks to exploit all that can be done with, I would say, the benefits we get from agile methods. Rapid prototyping. This is the idea of rapid prototyping.
Well, this is so interesting. Tao, if you have a question to ask, otherwise I would like just to wrap up with one final thing, very briefly, in just 2 minutes. What would you like then as a final greeting, or yes, actually a farewell, see you soon, so the participants, What will be the key takeaway that we'd like the audience to remember from your presentation?
From the presentation itself, the talk I'll be giving, I think the way I'm feeling about this stuff is, well, my key takeaway would be there's so much fun to be had. It's not over yet, and there's so much still out there. I feel like it's a coming together of many streams and many new methods, but maybe old problems and old takes at these problems. It's all coming together, and there's definitely a lot happening and not becoming possible. But we're not done yet, and there's so much still, to be done, and fun to be had, that it's worth just entering the game.
Wow. Okay, just one follow-up. Yes or no question. Are machine going to replace us as developers? And if so, in how long? How many years?
That's a provocative one. Are they going to replace us as developers? Obviously, you'd need to do a ton of caveats and so forth. But I think essentially, I believe yes. As developers, I think we're looking at transformative change. By when? I would think that the shift depends on where you're looking and what kind of task you're looking. But we're speaking, I would say, within 10 years, 10,
Okay.
15 years or so. So it's that horizon of time.
Well, plenty of time to reinvent ourselves, of course. So let's grab hold to all those tickets and follow this matter up. Sébastien, it has been a real pleasure talking with you. I can't wait to meet you in person, and especially to all of those participants attending and listening to the conference, both in presence and in streaming. I think they're going to have a great time. Thank you for this anticipation and this preview of your talk, and see you soon. That's it. It was a pleasure. Let's keep in touch, then. Thank you for the time.
For your future interviews, guys, I think you had quite a bit of background noise. I don't know where it came from.
Oh my gosh, sorry. I think it must have been me.
No problem. I see many bilingual people, especially expats, who have this thing, and it's a bit sad to witness. It's called linguistic erosion, because it's like, sea or wind blow continuously and then essentially smoothen out the surface of, say, rock. So I witnessed this, and I fight it as far as I'm concerned. Things you can do to actually fight it as a speaker, like sort of rejuvenate your own vocabulary, exposure to ways of speaking that have become current ever since you left. I see this French, for instance. I have some of people my age I went to university with, but some of the expressions that they use, expressions of the day, they're maybe a bit new to me, and I speak like we used to speak 20 years ago, which is not the same, expressions and a jargon and a slang, and that's important. Whatever you do, I always think of one thing, which is that learning and cultivating languages is always excellent gymnastics for your brain. I think the benefits of learning languages onto other, I would say, mental tasks, or you're asking your brain to do, this is excellent.
So we all know the benefit of learning an extra a foreign language, but now we have the tools where you don't need to learn the new language anymore. You can just put on your phone and it will translate for you. For example, government offices, the reception, where they talk to the people. The foreign people can just speak whatever language, and the screen, basically the glass in front of the counter of the receptionist will automatically translate that into Japanese and vice versa.
I've never seen this in action. I guess that, the technology is there, but I've never seen in like happening in a socially acceptable way, or in an everyday scenario.
Yes. So for me, as a foreigner, I think that's very convenient, and I would love that to be everywhere, basically. But then again, if it's available everywhere and everybody can have access to these tools, what is the point of learning another language?
I think it's an important question. I think it's not a given that you, in the future, just like I answered Luca earlier on programmers, I think it's just a fact that incentives are shifting, because there are other solutions to speaking with people from other cultures or languages than learning the language yourself. Incentives are moving, And so I think that we're going to see a sort of depreciation. So it's going to lose devaluation of language skills per se. So people who go on to study only languages, it's going to be more difficult to market this single skill. I speak several languages because there will just be less need for that. So this is important for people and for how they, think of their career and what studies they do. Obviously for universities, for the kind of courses they offer. I mean, it's got a lot of impact down the sort of labor market and economical mechanisms throughout industry. It's a fact, and I think that obviously we would rather see maybe the emergence of new scenarios in which we will need more language skills, and these might have to do with sort of creative or culturally competent communication, where the demand goes beyond just linguistics, but goes into culture and social skills. Okay, so currently, for instance, it's a soft skill to be able to, I don't know, a receptionist or a sales clerk. It's one of their soft skills to know how to deal with people in an agreeable way, or even with an unsatisfied customer in a way that makes the customer at the end of the interaction feel good, even though they are unsatisfied for some reason. And so this kind of skill, it's going up the ladder, the sort of, this kind of skill, this is very human still. This is one of the last things that machines can replace. It's got to do with empathy. Okay, nurses, people who care for elderly people or for babies, kids. These are super important humane skills that we will need more than just those language skills that we've been using so far. So I think it's something goes away and something appears. Something is needed less, but some new things become needed more. So watch out for that. In good chatting, Tao. I need to go back to
of course. Thank you so much for your answer.
Work. But it's been really good. And again, hi to Luca, and I hope the interviews go well. And
yes,
see you in New Year.
Thank you so much, and have a nice day.
Thank you.
Thank
Bye.
you, Sébastien. Bye-bye.